This is my week 5 reflection of software engineering. So, this week we dived into chapter 3 software engineering. Now, I'll be honest, before this lecture, I thought software engineering was just basically coding, but the lecture kind of flipped that assumption on its head. We looked at two really important things: why software projects fail so often, and what it actually means to be professional in this field. I'll cover both of those, and then I'll talk about how can I apply what I have learned directly to our group project. So the first thing that our lecturer walked us through was Chaos Report, a study that tracked real software projects for many years. The numbers were pretty shocking. Back in 1995, only 16% of the projects were completed on time and within budgets. However, those data improved a little till 2018. Only 30% of projects were completed on time and within budget. Still, 70% of the projects were not completed on time, and they were falling behind. Even today, this is a massive ongoing problem in our industry. So the lecture broke failure into three types. First, projects that succeeded. Those had involvement, executive support, clear requirements, and proper planning. Second, projects that were challenged. They were completed but they were late, over budget, and missing features. Those usually suffered from a lack of user input, including requirements that kept changing halfway through. And the third, projects that were cancelled or never used. Those had incomplete requirements, no user involvement, and not enough resources. The lecturer also brought up the Capper-Jones study from 2008, which broke down where errors actually come from. Code errors are the highest at about 38%, followed by design errors at 24%, then documentation, requirements, and bad fix errors. But here's the point that really hit me. The lecturer asked us, should we worry more about code errors or requirement errors? And the answer is requirement errors. Even though they are lower in percentage, but a requirement mistake made early gets carried through every single phase: design, code, testing, and the later you catch it, the more expensive it is to fix. Beyond just technical stuff, the lecturer also pointed out that as project grew larger, non-technical problems became just as dangerous. Things like poor leadership, bad planning, inexperienced teams, weak management, and not being willing to adapt when things change. The question number two was uh, about the professionalism in software engineering. Our lecturer started by making an interesting point. Unlike civil or mechanical engineers, software engineers don't have an official professional license. There is no professional engineer designation for us, except interestingly in Texas, where software engineering is officially a licensed discipline. So that raises a question: how should we actually become professional without that formal structure? Our lecturer gave us the IEEE and AEACM 8 principles for ethics in software engineering. Let me walk through them quickly. 1. Act in public interest. 2. Serve your client and employer while still keeping the public in mind. 3. Deliver the highest quality products as possible. 4. Maintain integrity and independence in your project judgment. 5. Managers must promote ethical leadership. 6. Protect the reputation of the profession. 7. Be fair and supportive to your colleagues. 8. Commit to lifelong learning. The lecturer also gave a simpler version: just 4 rules: respect others, strive for fairness, perform to your best capability, and follow the law. We also looked at some general principles like Davies' 15 principles, Roy's modern principles, and Wasserman's concepts. There were a lot of them, but a few stand out to me. Davies said, make quality number one, and people are key to success. Royce emphasized iterative processes and managing change, and Wasserman's concepts focused on things like abstraction, modularity, reuse, and metrics. What I took from all of this is that professionalism is not just about what you build, it's about how you build it, how you treat people, how seriously you take your own growth as an engineer. So, linking this to our software engineering project, so how does all of this connect to our group project? Honestly, in a really direct way, the Chaos projects told us that incomplete requirements are one of the top reasons that project fail. This week, our assessment 2 is due, and that requirements elicitation report. And this lecture is basically a warning to get our requirements right. Now, before we move into design and coding, a mistake at this stage costs 10 times more to fix it later. The failure factor also reminded me that user involvement matters. We should be checking back to our stakeholders regularly, not just gathering requirement once and disappearing. And on the professionalism side, the principle about being fair and supportive to colleagues is something that I want actively apply in our team. Good management matters more than good technology. Davis said that, and I think that's true for student teams too. If we communicate well and respect each other's work, we'll build something better. To wrap up, this week showed me the software engineering is as much about people, process, and ethics as it is about writing code. Failure is common, but it's not random. It follows patterns, and we can actually learn from the failure and avoid it. And being professional in this field means holding yourself to a standard even no one is watching. Thanks for watching.